Hi there, and welcome to this lesson. In this lesson, we'll be doing something very interesting. Okay, we'll be doing some WAEC revision. Okay, and basically, this time around, we'll be learning about indices. So, now what it is we're going to be going over some WAEC standard questions because you should be, at this point, you should be working towards your WAEC exams. And we'll be going over some WAEC standard questions, basically to get you accustomed to solving these type questions. Okay, really easy. WAEC questions are quite simple, but yeah. As the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help, and be sure to solve along with the questions. Okay, the examples. So yeah, let's jump right into the lesson. So indices. Now, laws of indices. Let's go over the laws of indices. At this point, you should be somewhat familiar with the laws of indices, but let's go over these laws one more time, okay, before we start attempting questions involving indices. Now, our first law is our product law, and basically, if you're going to solve any questions, particularly in WAEC, if you're going to solve any questions involving indices, you should have all of these laws well embedded in your head. So you have the first one. The first one we have the product law. Okay, and basically, if you have x to the power of a multiplying x to the power of b, so if you're multiplying two numbers with indices, the same base number with two indices, you pretty much have x equals a plus b. So if you have 2 to the power of 3 times 2 to the power of 5, it would equal 2 to the power of 3 plus 5, 2 to the power of 8. Okay, now the quotient law is quite the opposite. So the quotient law is division. So if you have x to the power of a divided by x to the power of b, it would equal x to the power of a minus b. The next one, zero law. Zero law is very easy. Anything raised to the power of 0 equals 1. Next law, negative index law. Okay, negative index law. And this one says that anything raised to a negative number, so if you have x to the power of minus a, what you have is you have a fraction with x to the power of a as its denominator. So you just take out the negative number and you go 1 over x to the power of a. So if you had, for example, 3 to the power of minus 2, you would have 1 over 3 to the power of 2. If you had x to the power of 5, x to the power of minus 5, you would have x 1 over x to the power of 5. It's that simple. So x to the power of minus a equals 1 over x to the power of a. Now, the power law, okay, this one is very interesting. So if you have a situation where you have x to the power of a all to the power of b, okay, so you have a number raised to a given index, and the whole thing raised again to another index, what you have is you have this as x to the power of a times b, okay, so x to the power of ab. So what you do is you multiply the two indices. And fine, I think is this the last one? Fraction index law. Okay, so basically when you have when your index is in fraction form, for example, you have x to the power of 1 over a, for you could have x to the power of 1 over 2, x to the power of 1 over 3, and when you have x to the power of 1 over a, what this is the 8th root of x. So if you have x to the power of 1 over 2, you find the square root, x to the power of 1 over 3, the cube root, x to the power of 1 over 4, the fourth root, okay, and so on. And yes, those are very important laws of indices, okay. And basically, when you're solving questions involving indices, the one thing you should be looking for particularly when you're asked to simplify, is you should be looking for you'll be looking to express whatever you're given in the base form, in the base number form. But let's do some examples so we understand exactly what that is. So we have example one. And example one says simplify 36 raised to the power of 1 over 2 times 64 raised to the power of minus 1 over 2 times 5 raised to the power of 0. Okay, and this is actually quite simple. This is a really simple one. Okay, it might look quite bulky, but it's actually really simple. So we have 36 to the power of 1 over 2, and then we have 64 to the power of minus 1 over 2, and we just apply negative index law to that there. And what we have is we have 1 over 64 to the power of 1 over 2, and then we have 5 to the power of 0 in the end. And then we apply our fraction index law. Okay, so because basically we have numbers raised to 1 over 2 and basically 164 raised to 1 over 2 as well. And what we have is we have the square root for both of them. Okay, so 36 to the power of 1 over 2 means square root of 36. 64 to the power of 1 over 2 means square root of 64. And then 5 to the power of 0, we just apply our zero index law there. And what we have is we have 1. Okay, so the next bit, we now have the square root of 36 as 6, the square root of 64 as 8, and we have 1. And when we work all of that out, we have 6 times 1 over 8 times 1. It gives us 3 over 4. Simple, straightforward. Okay, let's move on. Now, example 2. Okay, another simple one. Okay, ooh, this looks very interesting, somewhat bulky, but also very simple. Okay, and we have several laws at play here. We have a fraction index law, we have a negative index law. Okay, and we're going to start off with, we have 27 over 125 all to the power of minus 1 over 3 times 4 over 9 all to the power of 1 over 2. Interesting. Now, what we're going to do here, first thing we're going to work with that negative, okay? We're going to get rid of that negative number there. And what we have is we have the 1 over 27 over 125 raised to the power of 1 over 3. And when you have 1 over a fraction, you basically just flip the fraction. So what you have is you have 125 over 27 to the power of 1 over 3 times 4 over 9 to the power of 1 over 2. Okay, so now the next thing we're going to do is our fraction index law. So we have 1 over 125 over 27 to 1 over 3. And what that means is to find the third root of 125 over 27. Okay, and then similarly, we have 4 over 9 to the power of 1 over 2. And that tells us to find the square root of 4 over 9. Now we're going to distribute our roots on the fraction. So basically we have that we're going to have root of 125, cube root of 125 over cube root of 27 times the square root of 4 over the square root of 9. And we just simplify that out. The cube root of 125 is 5. The cube root of 27 is 3. Okay, the square root of 4 is 2, and the square root of 9 is 3. And we work that, and we end up with 1 whole number 1 over 9. Simple, straightforward. Third example. Okay, example 3. And okay, now this looks very interesting. Okay, we have to do some reasoning here. And it says if 2 to the power of n equals y, find 2 to the power of 2 plus n over 3 in terms of y. Okay, and basically what we have is we have this very interesting expression, 2 to the power of 2 plus n over 3. Okay, and what the question is asking us to do is to simplify this, express this in terms of 2n. Okay, if it tells you express because y 2n equals y, okay, so you need to simplify this till you get to the point where you have 2 to the power of n. Okay, and then when you have 2 to the power of n, you quite simply substitute y in. So you have 2 to the power of 2 plus n over 3, and you need to work this till you get to the point where you've simplified to the point where you have 2 to the power of n. And to do so, it's actually really simple. Basically, you have 2 to the power of 2 plus n over 3. And something interesting we have there, we have a product rule at play there. Okay, so we have that 2 to the power of 2 plus n over 3 is the same as 2 to the power of 2 times 2 to the power of n over 3. Okay, so that's our product rule at play there. Okay, and now we've done the first bit. Okay, so we're looking at that 2 to the, remember we're trying to get to the point where we have 2 to the power of n. So we're looking at that 2 to the power of n over 3. Okay, and we're looking to simplify that out. What we can do is we can say, first of all, 2 to the power of 2 is 4. Okay, and we can say n over 3 is the same as n times 1 over 3. Okay, and at this point you probably guess where we're going with this. We're going to apply the power law there. Okay, and the 2 to the power of n times 1 over 3 is 2 to the power of n raised to the power of 1 over 3. Okay, basically you have 2 to the power of n times 1 over 3. This equals 2 to the power of n all raised to the power of 1 over 3. And that's it. Basically, we've successfully obtained 2 to the power of n. And at this point, we can quite simply substitute our y, because we're told that 2 to the power of n equals y. So we can go ahead and say 4 times y to the power of 1 over 3. And what we have in the end is we have 4y to the power of 1 over 3. That's it. Very simple, very straightforward. Now, I think we have a few more examples. So these are really easy. How you finding these wire questions up until now? Very easy, aren't they? Example 4. Okay, so this time around we have an equation. Okay, and we have an equation, and this equation is coming in the indices form. How do we solve this? Now, I'll tell you just basically, if you're looking to solve an equation that an indices question, an equation that involves indices, all you have to do is to get to a point where you have the base number on the left and on the right equal. Okay, so at the moment we have our base number on the left is 2 and our base number on the right is 8. So we really can't do much about that. Okay, but then we need to apply our different laws of indices to find a way to get to the point where we have the base number on the left and the base number on the right equal. Okay, and the best way to go about this is to try to make that 8 2. Okay, try to simplify that 8, and basically 8 is 2 to the power of 3. So you should understand where we're going at this point. So we have 2 to the power of 6 equals 8 raised to the power of 5 minus x. Okay, and basically what this is, 8 is 2 to the power of 3. Okay, so what we have is we have 2 to the power of 6 equals 2 to the power of 3 raised to 5 minus x. And then we just apply our power law here. Okay, and because we have 2 to the power of 3 all raised to the power of 5 minus x. So basically that is 2 to the power of 3 times 5 minus x. Okay, and at this point we've gotten to a point where we have equal base numbers on both sides. So we will have 2 to the power of 6 equals 2 to the power of 3 5 minus x. And if you have this, basically, I believe you'd agree with me, if 2 to the power of 6 equals 2 to the power of 3 5 minus x, you would agree with me that quite simply 6 equals 3 5 minus x. So we do away with the base number, okay, and then you draw out the indices, okay, because you've gotten to the point where the base numbers are equal. So you put the base number aside, throw it, doesn't matter, okay, no longer relevant. You take out the two indices, okay, because if 2 to the power of 6 equals 2 to the power of 3 5 minus x, you would agree with me that 6 quite simply equals 3 5 minus x. And you just bring that out, okay, and from this point on you basically just have a very simple linear equation, and then you expand, and then you move your values around and you just solve, and you should end up with x equals 3. Simple, straightforward. So basically, when you're solving any question, be it wire questions or jam questions or IGCSE questions or SAT questions, anything at all you're solving that involves indices, basically, you really need to take your, first of all, you have all your laws embedded in your head, and then you always work to simplify to get a base number, a simpler base number. So for example, if you ever have a number like 125 in an indices question, you know you're going to be approaching simplifying that to become 5, okay, 5 to the power of 3. Or if you have 64, for example, you could be simplifying that to have 2 to the power of 2 to the power of 6. 64 is 2 to the power of 6, and so on and so forth. Let's do one final example. Example 5. Okay, now this looks interesting. Okay, bulky, quite simple. Okay, And what we have here, we have given that 9 to the power of 1 minus x equals 27 to the power of y, and x minus y equals minus 1 over 2. Find x plus y. And what you have here is you have a pair of simultaneous equations. Okay, but then the first equation is in index form, the second one is in linear form. So the first thing you want to do is you want to simplify the first equation. Okay, so you want to simplify that first equation, simplify it to the point where you have it in linear form. Okay, and then once you have that, you then solve the two linear simultaneous equations. Quite simple. But let's get right into it. So we have that index equation. Okay, we need to simplify that. So we have this here, and looking at these two numbers, with, like I said, when you're working anything in indices, just be think about the simplest base number. Okay, it's the best, it's the first approach. Okay, so you have 9 and 27. We're definitely working towards something that involves 3. Okay, and basically we're going to simplify 9 is 3 squared, and 27 is 3 cubed. Okay, and 3 squared always to the power of 1 minus x, and 3 cubed always to the power of y. And then we just apply a power law, so we have 3 2 1 minus x equals 3 3y, and we have equal base numbers. We can quite simply draw out equation. So we have 2 1 minus x equals 3y, and we expand and we just rearrange that so it looks neater. So basically what we have in the end is we have 2x plus 3y equals 2. So that is the equation from the index equation. Okay, that's your equation 1. Our equation 2, quite simply, is the other equation in the question. So we have x minus y equals minus 1 over 2. Now you go ahead and solve this. Basically, if you're solving this, you can solve this substitution method, elimination method, equal subject method. But one thing I advise you to do is to multiply that second equation by 2, so you get rid of that fraction there. So you can go 2x minus 2y equals minus 3. Okay, and you'll make solving that equation simpler. But if you solve that equation, you would end up with x equals minus 1 over 2 and y equals 1. Okay, and basically you have your values for x and y, and the question actually asks to find x plus y. So you have x plus y equals minus 1 over 2 plus 1. Okay, which will give you your answer, final answer, minus 1 over 2 plus 1, or 1 minus 1 over 2 equals 1 over 2. Simple, straightforward. Okay, and that would bring us to the end of this very simple lesson. So these are the kind of questions you can expect on your WAEC exam, and it's very important that you get very much accustomed to them now. Okay, and you go ahead and solve more of these type of questions on the worksheet. Bye for now.